Hey, what's up guys? Today we're going to learn how to calculate the derivative of a couple of radical functions using the formal definition. Alright, here it is. Alright, if you're watching this, then you probably have some experience already with the formal definition of the derivative, and you've probably used it to find the derivative of polynomial functions, which are generally simpler to deal with than the radical functions. But just to recap, the derivative of a function f prime of x is given as the limit as h approaches 0 of f of x plus h minus f of x all over h. And so if your function is the square root of 1 plus 3x, then that would imply that its derivative is the limit as h approaches 0 of the function evaluated at x plus h. So everywhere I see an x, I'm going to substitute x plus h. Alright, so there's my f of x plus h here. And then I'm going to subtract f of x. I'm going to put that all over h. Okay, so now first I'll simplify underneath the radical here, so I'll use the distributive property. So that's going to give me a 3x plus 3h. And I have my minus f of x all over h. Now, if you remember with the polynomial functions, the goal here is to get a factor of h in the numerator to cancel with a factor of h in the denominator. Because right now I can't safely evaluate my limit. I can't substitute my 0 in for h because then I'd have 0 in the denominator. And so I need to get a factor of h in the numerator to cancel with this h here. But the problem is my h is underneath a radical. And so if you remember, we can get things out from underneath a radical by using the conjugate. And so what we want to do is we want to multiply this numerator here by its conjugate, which is, if you don't remember, it's the conjugate of this is going to be the same exact thing, except you switch the sign. So I'm going to multiply this by the conjugate. So I'm going to recopy this. Except I'm going to do the opposite of this sign. So I'm going to do a plus sign. And you'll see why we do all this in a second. Okay, now the thing is, I can't just multiply all of this by this because then that actually changes the expression. And so I can't just multiply by the conjugate. I have to multiply by the conjugate divided by itself. And the reason I have to do this is because anything divided by itself is just 1. And so really all of this here in this box that I'm making, all of that boils down to just 1. So mathematically, I'm just multiplying this expression by 1, but you'll see that strategically we get some stuff out of it. So if you remember how to multiply fractions, right? This is just one big fraction multiplied by another big fraction, and so we have to do the numerator divided by the the numerator times the numerator, and then the denominator times the denominator. So it seems like this is going to get really ugly really quickly, but the conjugate actually makes our lives a lot easier, and you'll see what happens here, because I have to use the distributive property. So again, we're ignoring the denominators for now, we're just worrying about the numerators. I have to do the distributive property here because I have to do this times this, and then this times that, and then this times this, and then this times that. And again, it seems like this is going to get out of hand really quickly, but you'll see things work out pretty nicely. So again, we're going to do the first thing here, times the first thing there. And notice how they're exactly the same thing. So all that's going to happen is that these radicals are just going to cancel. So really, all I'm going to have is what's underneath this radical. Okay, so we just did the first one times the first one, and we got this. Now we have to do this times that. But before you write that, keep in mind that you're also going to end up having to do this times that, which is the same thing. Okay, so I'm going to say that again. This times this is the same thing as this times that. And since I'm subtracting them, it all just boils down to 0. So I actually don't have to write anything for those two multiplications. And then all I'm going to be left with is this second one here times this second one here. And again, those match. They're exactly the same. So all that's going to happen is that the radicals are going to cancel. But just don't forget your minus sign. So minus this times this, which is of course just 1 plus 3x. All right, and that's going to go into parentheses. So all that was for the numerators. And now we can go ahead and multiply our denominators. Okay, now you might be tempted to distribute here, but remember the goal is to get a factor to cancel in the numerator and denominator of h. So the goal is to get this thing to cancel anyway, so there's no sense in multiplying that through. All right, so now I will simplify the numerator. It's going to be minus 1 minus 3x. All right, and now I can go ahead and start combining like terms in my numerator. So I see I have a 1 and a negative 1, that'll be 0. I have a positive 3x and a negative 3x, that'll also be 0. So all I'm left with is a 3h in my numerator. Okay. And now I can get a factor of h to cancel, which is what we were after. So the h's will cancel, I'm left with a 3 in the numerator. And now I can safely substitute my 0 in for h, because even though that h is in the denominator, it's not alone in the denominator, there's other stuff. And so me substituting 0 in for h is not going to make everything turn to 0. So I can go ahead and evaluate the limit at this point. And so just this 3h will go away, so everything else I can copy down. Okay, and then I can combine these. So instead of saying square root of 1 plus 3x plus another square root of 1 plus 3x, I can call that 2 square roots of 1 plus 3x. And there is your derivative. Okay. Now we're going to do one that's a bit more complicated here, but we'll start it the same way. So everywhere I see an x, there's 2 spots now. I'm going to substitute my x plus h. and then also in there. Okay, so all of this is just my f of x plus h. Now I'll subtract f of x. Now this is going to all go into parentheses. Okay, so there's my minus f of x, and all of this, oop, forgot my limit notation here. And all this is going to get divided by h. All right, now I'm going to simplify. I'm going to do all my distributive property. So here I have a 3x plus 3h. Then I have a minus 2x minus 2h. And then I'll distribute my negative sign through. It's going to be a plus 2x all over h. All right. So now I can simplify a little bit. I see I have a negative 2x and a positive 2x, so that'll make 0. But I still have this minus 2h. All right. Now, this is where it's a bit tougher than the last one. So again, I need to start thinking of ways I can get h out from under this radical here so I can cancel it. And the conjugate is the move I want to make, but the problem is I have this minus 2h here. So I'm not in a position to use the conjugate because I just want my radical expressions there. But since all of these are over the same thing, they're all over h, I can split this one big fraction into two fractions and then add them together. So what I'm going to do here is I'm going to take my negative 2h and put that over h. And then I'm going to add to that the rest of the fraction. So I'm going to add to this part the other parts, so I'm going to copy those down. Minus square root of 3x plus 4 over h. And the reason I'm allowed to do this is because of how adding fractions works, right? Since I have like denominators, then I can simply add my numerators together, and you'd see I'd end up with this. So if you ever have one big giant fraction over a particular denominator, you can split it into a sum or a difference of fractions over that same denominator. And so what this allows me to do now is I can use my conjugate trick on this part of on this fraction here. So I'm going to go ahead and set that up. And remember, you have to do the conjugate divided by itself so that you're really just multiplying by 1. Okay. So now, let's, before I actually do my multiplication of the conjugate, let me go ahead and cancel my factor of h here, so I'm just left with a negative 2. All right, and now I will do this multiplication. So remember the distributive property, this times this, well, that just undoes the radical. So I have a 3x plus 3h plus 4. And then remember, this times this Oh, this should be a plus sign, sorry. That's the conjugate, right? The opposite of this sign. So now, this times this is the same as this times this. And since we're going to subtract those two products, that all just disappears. And then, of course, I'm left with this times that, which is just going to cancel the radical. But remember, we're subtracting that. So minus, then in parentheses, I'm just going to do 3x plus 4. Okay. And this is all over, we have to multiply the denominators now. This is all over h times 3x plus 3h plus 4 under the radical plus 3x plus 4. All right. Now I will simplify. So I still have my -2 over here. And now I'm going to do this distribution in one step and then combine like terms. So I have a 3x and a -3x, that's going to go away. And then I have a +4 and a -4, so that's going to go away, that's 0. And I'm just left with a 3h. And now I have a factor of h to cancel here. And so I'm just going to be left with my -2 plus 3 all over this stuff here. Okay, and now I can safely substitute my 0 in for h. So I'll go ahead and do that. So I'm left with 3x plus 4 plus another radical of 3x plus 4. And then, of course, I can combine that to be 2 square roots of 3x plus 4. And this here is your derivative of the function. All right, guys, so these get pretty ugly pretty quickly, but the conjugate is the way to take care of these. All right, with that said, guys, it's been demonstrated.